Hello, my name is Adrian Rodriguez, and this is Project 4 of Dr. Khan's Electrical Mechanical Systems. In this project, we will be creating an ultrasonic sensor circuit, and based on the distance that the sensor is picking up on the nearest object in inches and centimeters, one of two actions will happen. Either one of these two LED lights will be turned on, either the buzzer will be buzzing or not, and either the microservo motor will stay in its original position or rotate 180 depending on the distance that this ultrasonic sensor is detecting on the nearest object. So the materials that we will need for this project is one ultrasonic sensor, one buzzer, two LEDs, one microservo motor, circuit cables, an Arduino Uno microcontroller, a serial cable, and a computer. So once we set up everything on the breadboard, ensuring that everything that such as the shorter pins are grounded and placed on the breadboard, all four pins are established, we could then go to our coding. As in the beginning of our coding, we start by defining where everything must be placed on the microcontroller. So if we look, the trigger pin must be on the signal 13, echo pin must be on the signal 12, LED 1, which is the blue LED, must be on the signal 7, LED 2, which is the red LED, must be on the signal 6, the buzzer must be on the signal 2, and the microservo motor must be connected to the signal 9 on the microcontroller. And once we set up where our components must go on the microcontroller and everything is set up on the breadboard, we could then start the loop section of our coding. Now what this loop section is doing is it is getting the flight time data that the ultrasonic sensor is collecting from the nearest object. And what it's doing is getting that flight time data and sending it to the microcontroller. And with this, we allow for the microcontroller to convert the flight time data into distance in inches and centimeters. So what this void loop is doing, it's constantly getting the flight time data from the ultrasonic sensor and sending it to the microcontroller to constantly be converting that flight time into distance in inches and centimeters. And then so once we have the distance of the nearest object picked up from the ultrasonic sensor, we can now begin to impose certain conditions based on the distance that the ultrasonic sensor is picking up on the nearest object. So right here we say if the distance is greater or 20 centimeters, the blue LED will be on, the red LED will be off, the buzzer will not be buzzing, and the microservo motor will stay in its original position. Otherwise, if the distance is less than 20 centimeters, the red LED will be on, the blue LED will be off, the buzzer will be buzzing, and the microservo motor will rotate 180 degrees. And then it's right here saying otherwise, if the distance is greater than 500 centimeters, it will print out of range. And then right here, we could just go down to put in our serial monitor, the distance that we want it in, which is inches and centimeters. And then we're gonna have a delay of 100 milliseconds, meaning that the new distance that the ultrasonic sensor is detecting on the nearest object will show every 100 milliseconds. So that's what's happening here. It's updating every 100 milliseconds to show that the distance that the ultrasonic sensor is detecting on the nearest object, which in this case is that green bottle. So we see right here that the distance that the ultrasonic sensor is picking up on that green bottle is around 21 centimeters. So since it's at 21 centimeters, it's greater than 20 centimeters. So in that case, the blue LED will be on, the buzzer will not be buzzing, and the microservo motor will stay in its original position. But once we put an object closer than 20 centimeters to the circuit, we will see how the red LED will turn on, the buzzer will begin to buzz, and the microservo motor will rotate 180. So let's put my hand. So we saw how the microservo motor rotated, and that is because the ultrasonic sensor is detecting my hand, and it is detecting that the distance is less than 20 centimeters. And then once we remove my hand, we'll see that the nearest distance it is picking up again is of the green bottle, and that is once again outside of 20 centimeters. So once that happens, the blue LED light will turn back on, the buzzer will stop buzzing, and the microservo motor will rotate back to its original position. So let me just show you guys again. So that is outside of 20 centimeters, within 20 centimeters, outside of 20 centimeters, within 20 centimeters. So yeah, and then let me just put it right here. So it's more than 20 centimeters. So the blue light is on, the buzzer is off, and the microserver motor is in its original position. And then once it goes below 20 centimeters, so it's below 20 centimeters, so the red LED light is on, the buzzer is buzzing, and the microserver motor rotated 180 degrees. And this is just an example of how we use ultrasonic sensors in everyday automation devices, such as vehicles, as they release a buzzer once they detect that a vehicle is getting too close in distance to another object. Or in sinks, for example, those have ultrasonic sensors that let the faucet run water when the sensor detects a hand near the sensor. And another object could be doors, as when they sense a human walking up to the door will open. These are just a couple examples of how we can use automation devices in everyday lives to help make everyday tasks easier. So greater than 20 centimeters, blue light on, buzzer off, microserver motor in its original position. Less than 20 centimeters, red light on, buzzer buzzing, and the microserver motor rotated 180.